Welcome to 3.2 Complex Numbers Part 2. Today we are multiplying two complex numbers. We are going to use the distributive property or the FOIL method, just as you do when you multiply real numbers or algebraic expressions. One note you need to remember from the previous lesson is that I squared, I is equal to the square root of -1. And when you square that, you get -1. So kind of keep that in mind. We're going to use that concept. So let's look at part A, example 5, part A. So we take 4i times -6 plus I. We're going to distribute. So 4i times -6, 4i times I. Simplify. 4 times -6 is -24, and then don't forget about your I right there. 4i times I times I is I squared, so it's 4i squared. Now remember, I squared is the same thing as -1. So anytime you see I squared, you can change that to a -1. Simplify, we get -24i minus 4. Now to write that in standard form, you write your real number part first and then your I second. So to write this in the correct form, you write it -4 minus 24i. Let's look at B. B is a binomial times a binomial, and we are going to, if you remember back in algebra, FOIL, or just distribute. So you take both 9 and -2i and multiply it by -4 and 7i. So let's start with the 9. So 9 times -4, -36. 9 times 7i is 63i. And then we move on to the -2i and multiply it by everything. So -2i times -4 is a +8i. -2i times 7i is a -14. I times I is I squared. Simplify by combining like terms. So we combine the i's. So -36 plus 71i minus 14i squared. And see, we see the I squared. We can change that. We can change that to -1. So minus 14 times -1. Simplify that. So it's plus 14. Add like terms. -36 plus 14 is -22. So -22 plus 71i. And this is in standard form. The real numbers are first, and the imaginary part is second. So let's look at example 6. This imaginary numbers enables us to solve quadratic equations and get, when we couldn't solve them, we can actually get imaginary answers now. So let's look at A. So we have x squared plus 4 is equal to 0. We're going to subtract 4 from both sides. And I get x squared equals -4. All right, so before we could not solve this because x squared can never be -4, but now we can with the inclusion of the imaginary numbers. So we're going to take the square root of both sides. Don't forget about the positive negative, okay? So x equals positive negative square root of -4. We need to simplify that. So that's -1 times 4. The square root of -1 is I. And the square root of 4 is 2. So that's positive and negative 2i. Let's look at B. We have 2x squared minus 11 equals negative 47. So we're going to add 11 to both sides. 2x squared is equal to negative 36. Divide both sides by 2. X squared equals negative 18. We're going to take the square root of both sides. Don't forget about your plus and minus. So x equals positive negative square root of negative 18. I noticed that 18 has a factor of 9, so let's write it that way because I know the square root of 9 is 3. So break out that negative 1, 9, and 2. 9 times 2 is 18. So the square root of negative 1 is I, the square root of 9 is 3, and 2, the square root of 2, we can't do that evenly, so that stays under the radical. So this ends up becoming positive negative 3i square root of 2. Let's look at example 7. So finding zeros of the quadratic function. Yes, if it has an imaginary solution, technically it does not actually cross the x-axis, but they do have imaginary answers. So we're finding 0, so we set the whole thing equal to 0. So 0 equals 4x squared plus 20. Subtract 20. Negative 20 equals 4x squared. Divide both sides by 4. Negative 5 equals x squared. We are going to take the square root of both sides. Don't forget about your positive and negative part. So we have x squared, not x squared, just x equals positive negative square root. Now we can break that up as negative 1 times 5. The square root of negative 1 is I. So positive negative I square root of 5 is equal to x. That is the rest of lesson 3.2. Remember, you break this up, you simplify radicals. So if you're struggling simplifying radicals, please get extra help. I am here for the rest of the period, okay? Need help? Let me know. Bye.